Hi all, I'm Surati from Faculty of Electronic Engineering and Technology FK10 UNIMED. So I will present our project Smart Waiting Area for Special Needs Passenger at Train Stations, which is designed to improve accessibility, safety, and comfort disabled and elderly users. So this is our team members. This project is collaboration between me, myself, Dr. Vijaya, and my student, which is the Linges, Aiman, Zikri, and Zuhaili. Together, we combine the expertise in electronic, IoT, and inclusive design. Our core innovations for this project introduced in 5 core innovation, which is integrated health monitoring directly in waiting areas, a dual microcontroller system with ESP32 and Arduino, a real-time IoT dashboard for monitoring, smart access and occupancy control, and alignment with the Sustainable Development Goals, especially in health, innovations, and inclusive communities. Public transport waiting areas are often ignore the needs of disabled passengers. There are no health monitoring, poor emergency response, and risk overcrowding. So, to bridge this gap, we propose the SAWA, which is the Smart Accessible Waiting Area, which integrated RFID entry, occupancy sensor, and real-time health monitoring in order to enhance the safety, comfort, and also the autonomy. So this project have the 3 clear objectives, which is the first one is to develop an inclusive smart accessible waiting area SAWA that supports the needs of elderly and disabled individuals, especially in train stations. The second one is enable the real-time monitoring of pulse, temperature, and also the SpO2 for safety. And the last one is to implement an IoT-based alert and control system for timely emergency response. So, this slide shows the overall flow of our experimental setup. So, which is covered on the system design, hardware development, and also the software development. The process begins when a passenger scans their RFID card. So if the card is valid, the system allows entry through the server control gate. Then the IR sensor detects the occupancy and regulate the number of people entering. Once seated, passenger can use the handrail with the integrated pulse and temperature sensor for real-time health monitoring. Any abdominal readings or SOS button presses are instantly sent to the server and displayed on the dashboard. This flow ensures that access, monitoring, and alert work together seamlessly. So here you can see the block and the schematic diagram of the system. So we designed a dual control architecture, which is the Arduino Uno, which is handle the RFID access and also the occupancy monitoring, while the ESP32 manage health sensor and emergency alert. The ESP32 connect to a cloud server via the Wi-Fi, sending a real-time data. This separation of tasks improve the reliability and also the efficiency, the ensuring both access and health monitoring can operate simultaneously without delay. For the hardware development, which is covered under prototype hardware itself. So for the prototype, we use lightweight and affordable material to build a model of the train station waiting area. So the RFID scanner and servo motor will control the entry gate. So IR sensor will detect and count the passenger entering. Pulse and temperature sensor are placed in the straw box on the handrail for easy health monitoring. Then we have the sensor. They are protected with a plastic film to avoid damage while maintaining accuracy. All wiring will arrange neatly using a break box and jumper wires for stability. So all of the setup demonstrate how low-cost material can still deliver a full functional of the prototype. So for the software development, on the software side, we develop a real-time monitoring system using the Express server and the Socket I/O. So the ESP32, we send the sensor data, which is the pulse, SpO2, temperature, and also the button status to the server as a JSON. So the server then broadcasts the data instantly to all dashboard clients without needing a manual refresh. So this will allow two-way communication. So as soon as a passenger vital change or emergency is triggered, the dashboard update in less than 100 milliseconds. So the architecture is fast, scalable, and also ensure the accurate real-time monitoring. So let we see what is the result and discussion for this project. Okay, this is our prototype, the real prototype. So the integrated prototype successfully combines health monitoring, access control, and also the occupancy management. So data from the sensor displayed locally on an OLED screen and transmitted in real time to the dashboard. The system is programmed to trigger alerts automatically when abnormal vital signs are detected or when the SOS button is pressed. This means passenger can receive immediate assistance without delay, improving safety and response time in emergency. So for the system performance, the table shows the monitoring results and the behavior analysis that we characterized during this project. So we tested the system against health threshold like bradycardia, tachycardia, low SpO2, and also the high temperature. So the system reliability detected and responded to abnormal condition, confirming its accuracy and reliability. So the OLED screen shows the conditions of the passenger. So for the web server performance, the web server proved the P fast and stable. So data sent every 3 seconds. So the request process in around 50 to 80 milliseconds. So the dashboard updates in under 100 milliseconds. So logs generated we get under the 200 milliseconds. So even when the ESP32 disconnected, the system recovered smoothly. So this shows the system is ready for the real world deployment in train stations. So we come for the conclusions. In conclusion, SAWA offers a novel integrations of health monitoring, access control, and occupancy management. So DASP32 system track vitals in real time. RFID and IR sensor regulate the safe access and the crowd levels. And also, the web dashboard give live updates for both user and operators. So this holistic design make public transport more safer, smarter, and more inclusive. So, let's watch the video together. So thank you for listening. We hope this project can contribute to more inclusive transport system and we welcome your questions and feedback. Thank you.